Okay, so think about this for a second. How do you possibly capture our reality, something that's smooth and continuous and flowing, on a computer which only thinks in distinct, separate points? I mean, it feels impossible, right? Kind of like trying to draw a perfect circle using only square Legos. Well, today we are diving deep into that exact problem. This mind-bending quest to model reality itself and the strange, almost uncontrollable digital substance that scientists had to invent to even try.
So here's the game plan. First, we'll get into the weeds of that fundamental mismatch between our world and the digital one. Then we'll explore the absolutely wild idea of an uncontrollable fabric that was created to bridge that gap. After that, we'll see why AI might be our only shot at taming this thing. And you're going to want to stick around for the end, because that's where we uncover the ultimate prize in this whole quest, a theoretical object some are calling the carrier ball.
All right, let's dive right in. Section 1. We've got to start with the heart of the problem here. This deep, almost philosophical conflict between how our universe seems to work and how a computer actually thinks. So on one hand, you've got our reality. It's like a river. It's continuous, it flows, there are no gaps. But a computer's world, that's more like a connect-the-dots drawing. It's just a grid of separate, individual points with nothing in between. You see the problem? They're speaking two totally different languages. So how on earth do you get them to communicate? How do you build a bridge over that massive gap?
Well, how did scientists even attempt to build that bridge? They came up with this really fascinating but also deeply imperfect solution. And that takes us right into our second section, modeling a continuous reality.
You know, this quote just nails it. Since we literally can't calculate every single infinite point in reality, we have to fake it. We have to simulate the space between the points. This mathematical in-between is basically scientists admitting, hey, we can't actually model reality directly, so we have to invent this thing to fill in the gaps. And that thing, that bridge, it has a name: the elastic fabric. Now, a great way to think about it is this. It's less like building with digital bricks and more like sculpting with digital clay. It's this simulated, continuous substance that exists between the points the computer can actually see, and it's what gives the model that sense of flow and connection. So, the process basically goes like this. First, you just have to accept that reality is continuous. Easy enough. Second, you create this simulated elastic fabric to act like reality. And third, and this is the really clever part, you interact with that fabric using a grid of points in space and time. Imagine you've got a giant sheet of rubber stretched out. The computer can only poke it in specific spots, but when it does, those pokes create ripples and waves that travel across the entire continuous sheet. That's the idea. It's an absolutely brilliant idea in theory, but here's the catch. In practice, it creates this massive new problem. This digital fabric, it turns out to be almost impossible for us to control. And this is the paradox at the heart of it all. If you just create the fabric and leave it alone, it actually behaves a lot like our universe. Energy spreads out, things dissipate, it looks really natural. But the second you try to control it, the moment you try to sculpt a specific, stable shape in one little spot, the whole thing just falls apart. You can't make anything that actually lasts. Honestly, the best analogy is that it's like trying to sculpt with mist. You can wave your hand through it, you can create a little swirl for a second, but you can't make a solid, lasting object. Any energy you pump into it to try and form something, just poof, it dissipates and spreads out everywhere. So if we humans can't get a grip on this digital mist, what can? Well, as we head into our fourth section, a new hero enters the story: artificial intelligence. So why AI? Well, because this fabric is basically a storm of numerical data, way too complex for any human mind to really get a handle on. But an AI can dive right into that storm. It can poke and prod and twist that fabric millions of times a second, learning from every little ripple and actively hunting for the hidden rules that could finally let us create those stable shapes we've been looking for. The AI's mission then is crystal clear: get more and more grip on this wild digital substance. It's just this relentless process of learning, experimenting, and trying to find the secret language of this simulated world. It's a quest to finally tame the mist.
And here's the really cool part. The AI isn't just poking around randomly. No, it's on a very specific hunt. It's searching for one incredibly elusive structure that many researchers believe could be the key to, well, everything.
After all this searching and all this complexity, it all boils down to finding this one special shape, a structure that can finally hold itself together inside the fabric. And let's be clear, finding this thing isn't just another small step forward. It is widely considered to be the holy grail of this entire field of research. It's the ultimate prize. So what is this holy grail? It's called the carrier ball. You might also hear it called a fermion carrier topology or a carrier ball vortex. But what it really is at its core is a stable, self-contained, ball-shaped twist in that elastic fabric. It would be the very first solid object ever sculpted from the mist.
So why is this one little ball so unbelievably important? Because it would be the first real building block, a stable piece of what you could call matter in this digital world. The theory is, if this structure can be made, it would allow the fundamental laws of physics, the symmetries that govern our own universe, to finally work properly inside the simulation. It would be the key to modeling reality as it actually is.
And that brings us to the final, really mind-bending question. We started out trying to model reality, but we ended up creating this uncontrollable digital mist. We then had to unleash an AI just to try and tame it. So if that AI actually finds the carrier ball, has it just solved a complex computer problem, or has it accidentally unlocked the fundamental source code of reality itself?